Okay. The next technique is called nodal analysis, and this is again a method used to analyze multi-source circuits. So nodal analysis is pretty similar to mesh analysis, with the difference is that all sources in nodal analysis have to be current sources. So if you have a voltage source, you have to find a resistor that is in series with it and transform that into a current source. We are going to use nodes in the circuit, so it's important to us to define properly what a node is. So node is a region where 3 or more component terminals are joined. So right here, is this a join? I mean a node? No, it's not a node because I have 1 and 2 components connected here. So this is just a connection. It's a connecting terminal, not a node. Node is something like this. You see here, I have 1, 2, 3. I have 3 components, and this is what is 3 or more components need to be connected to that point in order for that point to be considered a node, okay? When we are doing nodal analysis, we have to choose a reference node that serves as a ground common with respect to which the voltages to all nodes are measured. It's very important to be wise how to select your common or your reference node. The way you choose it is see the whole circuit as a whole and understand which node has the most amount of connections, which node has the most connections to, and that's the node you want to make your reference. Why? Because the voltage at that node is going to be 0. So if most of the things are connected to that point, you already know that that is your 0. So it makes it easier, okay? So sometimes, like in the example right here on the right, it makes it simple because yes, this is the node that has more of the items connected, but sometimes it is not as straightforward and you just have to choose one. Whether that is the best selection or not, is just up to your discretion, and then you'll find out once you start solving the circuit if that was a good decision or not. But you only can become better and better at selecting your nodes by practicing, by doing and solving several circuits over and over. That's how your eye is going to get trained to say, okay, this is the best place for my reference node. And another thing is that we always assume the current flows from higher voltage to lower voltage nodes, okay? We always assume the current goes from high to low, just like water, right? Like a water stream, right? Water always runs from high to low. So let's jump into the example. It says here, use nodal analysis to find the voltage across the 4 ohm resistor. So this is the voltage that they are interested in, into the 4 ohm resistor. So the first thing to do before we start solving here is for us to transform this. It has to be taken from a voltage source into a current source. So here is easy because we have a resistor right next to it in series. So we use Ohm's law. 2 divided by 2 gives me 1 amp. I put the same direction of the current as for my voltage. I take my resistor and I locate it right in parallel to the source. I choose my reference node as being this one right here. All this right here is the same point. It is just a stretch like this so that we can put it as a reference node. So we said that this is what's going to be a reference node because most of the components of the circuit are connected to here. So it's a good point for us to put that as reference node. And we are going to connect that to ground to visually establish or say that it is a 0, that all the currents are going to come to this node. Why? Because current always comes from higher to lower potential. So we are going to assume all the currents are coming this way, are finding its way to here. So that's important. We are going to choose or identify our nodes So here is going, the first point is going to be called B1 or no one, because we want to, this is no one because we have 3 different connectors to here. This is no 2, we have 3 different components connected to that. In order for us to do nodal analysis, we have to do KCL. That's important, okay? So KCL, we are going to write everything in terms of currents. Just like in mesh analysis, we write everything in terms of voltages, we are going to write everything in terms of currents. That's why we want this to be a current source, not a voltage source. So let's move on to the next one, and right here, I'm going to write the currents for each single point. So I'm going to do nodal analysis or KCL at this point right here. So I'm going to say that this current is coming into the node, so it's positive. Everything leaving the node, according to KCL, is going to be negative. So the current across these 2 ohm resistor is going to be the voltage across this resistor divided by the resistor. So the voltage across is going to be V1 minus this other node, but this node is 0. So in reality, it's just V1 minus 0 over 2, which is actually only V1 over 2. Then I'm going to find the current going across this 4 ohm resistor. So this 4 ohm resistor is going to be, we always assume the current goes from higher to lower. So we assume that V1 is higher than V2. So current is going to be traveling from left to right. So it's going to be V1 minus V2 because it's a voltage difference over 4. So V1 minus V2 over 4 is the current going across this resistor. Then I do the analysis at V2. So right here, I have what is the voltage going across this resistor right here. So I have V2 minus 0 over 8, which is V2 over 8. So I have described all the quantities in terms of currents. Now I'm ready to do KCL at V1 and V2. So I'm going to do KVL at V1. So right here, I'm going to say that entering is positive, or the other way we can say KCL is that the sum of the currents entering is equal to the sum of the currents leaving. So entering is 1 is equals to the sum of V1 over 2 plus V1 minus V2 over 4. So this is the KCL node here. Now I'm going to do KCL at node V2. So right here, I have a current. This current right here across 4 ohm resistor is entering. This 2 amp current is also entering. So I'm going to have 2 plus V1 minus V2 over 4 is equal to this current leaving right here, which is V2 over 8. So now I have written my 2 equations. I just need to simplify them to have it in an easier way to solve them. So if I multiply this by 4, I get my equation 1. If I multiply this by 8, I get my equation number 2. If I rearrange my voltages, I get a summarized version of the equations. And now here they're using this other method called Kramer's method, which is more like a matrix method, and it's easy for 2 equations. So let's see how they do it so that we can have more options. But in reality, once you have these 2 equations right here, where you can solve for B1 and B2, you can use any method you like, okay? Here they're going to find the determinant of A, which is just all the coefficients of the voltages, and then we are going to write 2, 3 and 2, minus 1 and minus 3, we just cross multiply, 3 minus negative 3, then we subtract the negative 1 by the 2, and then we solve it, and then to find B1, we replace the column of the B1 by the equal to. So instead of B3, 2, I'm going to for 4, negative 6. The B2 stays the same. I divided by my determinant. I solve right here and I get 4 volts. For B2, I do the same. I keep B1. I replace B2 coefficients by the equal to of the equations, divided by my determinant, and I find A voltage. I don't spend a lot of time here because this is some simple math. You should know that. If not, look it up. And if you don't feel comfortable, you can use the calculator, you can use the substitution method, you can use any way that you learn in algebra to solve a system of equations, a 2 by 2 system of equations. So that should be pretty straightforward how to solve. The key concept here and the key important point right here is that you have to be careful of finding the node that is referenced and knowing that everything is going to go through that node. Know that when you are doing KCL, entering is equals to leaving. So this current right here is leaving, like the current for 4 ohm is leaving for this one, but it's entering for this node. So that is some key concepts that you have to remember. Once we have all the voltages, we are going to solve for, we're going to plug them into this definition where we have B2 minus B1 minus B2 over 4. So we are going to divide it by 4, right? So right here, B1 was 4, B2 was 8. So actually our direction of the current is wrong. The current is actually running from here to that. So it was stated here that B2 is actually bigger than B1, but since it's a difference, we just flip them. And now we have A minus 4 to get a positive value for voltage, so we can get a positive value for the current. If we didn't notice that, we would have gotten a negative 1 amp, which means current is not going this way, current is actually going that way. So keep always in mind, negative sign in front of a current means reverse the direction of the current.